In this module, we're going to talk about balancing chemical equations, how to do it and what it means. So the easiest thing really is to start out with an example. But before we do that, a balanced equation means that we have the same number of atoms of each element on both sides of the arrow. What this is, it's just an application of the law of conservation of mass. Matter can be neither created nor destroyed, which means that we have to, if we have 17 potassium atoms on the left, we have to have 17 on the right. Otherwise, either we created one from nothing or we made one disappear magically, which doesn't happen. So all we're going to do, okay, is put coefficients, numbers, in front of these formulas. And when you put a number, a coefficient in front of a formula, it applies to that every atom in that formula, but none of the other formulas. So let's look at this. All right, we have iron 3 nitrate reacting with potassium sulfide to make potassium nitrate and iron 3 sulfide. There's a couple of tricks that can make it easier. One is that if you see a polyatomic ion that appears on both sides of the arrow, you can treat it as just one thing and balance it by itself. You don't have to, but it can make things a little easier. Also, another trick is that if you see, we don't have one here, but if you see an element that's not combined with any other element, if we just had like pure iron or nitrogen gas or something, leave that by itself. Leave that for last, because you can put a number, any coefficient in front of that, and it won't affect anything else in the equation. But here, if you put a number in front of potassium nitrate, it's going to affect what number we have in front of potassium sulfide and so on. So leave the uncombined elements for last, but we don't have any here. So I'm going to start with iron. We have one iron atom here, and we have two iron atoms here. Remember, you cannot mess with the subscripts. You can only use coefficients. So we need two irons over on the left. So I'm just going to put a coefficient of 2 in the front of that. Now, see, that changed something. Now, instead of having 3 NO3s, 3 nitrates, now we have 2 times 3 is 6. You see that? It's 2 times 3 is equal to 6 nitrates here. Here we only have 1 times 1 nitrate over there. So I'm going to put a 6 here. That's the only thing I can do to affect how many nitrates I have on the right. Now I have 6 nitrates on both sides. I have 2 irons. Now potassium. Now I have 6 potassiums on the right, but only 2 on the left. So guess what? I have to put a 3 in front of here, because 3 times 2 is equal to 6. Now I have 6 potassiums. Okay, let's look at the last one, sulfur. 3 times 1 is 3. There's a 1 implied here. So 3 sulfides, 3 sulfides. Everything's balanced. 2 irons, 6 nitrates, 6 potassiums, and 3 sulfur sulfides. Now, the question up here is the way that I often ask, not just me, but a lot of people ask balancing questions on a multiple choice exam. So when this is balanced, what is the sum of its coefficients? So the sum of the coefficients would just be 2 plus 3 is 5, 2 plus 3 is 5, plus 6 is 11, plus 1 is 12. Watch out for that 1. A lot of times people stop at 11. They don't see a number there, so they don't add it, but there's an implied 1 here. So 2 plus 3 is 5, plus 6 is 11, plus 1 is 12. And that's our answer. The sum of the coefficients is 12. So let's do another example. Let me show you a few other tricks. So in this one here, this unbalanced equation, you see this oxygen by itself? That's an element that's not combined with any other elements. So we're going to leave that for last. Now, so we're going to either start with carbon or hydrogen. Doesn't matter. So let's start with carbon. There are 5 carbons here. So I'm going to put a 5 in front of the carbon dioxide here, because I need to have the same number of carbons on both sides. So carbon's good. Now I have hydrogen. There's 12 over here, 2 here, so I'm going to multiply 2 times 6 to get it to be equal to 12. So carbon's good, and hydrogen's good. Now the oxygen. So remember, we left this for last because we know we can put any number at all in front of this oxygen here. So all we have to do is make the number of oxygens over here balance this. So 5 times 2 is 10, plus 6 times 1 is 6. We have 16 oxygens on the right. Now watch this. We have an oxygen here. We definitely do not want to put any coefficient in front of this if we can help it, because then everything else changes. We have to start again. By the way, sometimes when you're balancing equations, you get stuck in this like it's a vicious loop. You change one thing and everything else changes, and you keep going back and forth. If that happens to you, just stop. Don't get sucked down that path. It'll drive you crazy. Just stop and start fresh with a different element as your starting point. But anyway, so we need 16 oxygens over here. We have, let me write that down. There's 16 oxygens on the right. We have 3 over here. Well, this one here, we're going to leave it alone. So that really means we need to get 15 oxygens from this. So all you have to do, okay, whatever number we put here as a coefficient, we're going to multiply by the subscript, the 2. So we want to know 2 times what, or 2 times x. 2 times what is equal to 15? Well, x is equal to 15 halves, right? So let's put the 15 halves here. And now we have 15 halves times 2 is 15, plus 1 is 16 oxygens on the left. It's balanced. Now here's the thing. You don't want to leave it like that, because whenever you're asked to balance the chemical equation, remember this now, it should always be the smallest whole number coefficient. So it has to be the smallest set, and it has to be whole numbers. So all we do now, and you always do it this way, if you have a fraction, whatever the denominator is, you multiply every coefficient in that whole equation by that. So we're going to multiply the 1 here by a 2. It becomes 2. 15 halves by 2, and that just makes this 15. The 5 by a 2, which makes this a 10. And 6 by 2, which gives us our 12. So now the question might be, what's the coefficient when this equation is balanced for water? It'd be 12, or carbon dioxide would be 10, or something else. Or what's the sum of the coefficients? 2 plus 15 is 17, plus 10 is 27, plus 12 is 39. And there you have it.